Hello everyone. Today we are going to build an Alexa skill using AWS Lambda and Serverless framework. The skill which we are going to build will be a cryptocurrency price tracker using CoinMarketCap's public API. So without wasting any time, let's quickly start what we are going to build. So what we are going to build is an Alexa skill using Alexa's skill kit. So just like in Android, you have Android SDK, we have Alexa Skills Kit to develop applications for Amazon Echo devices. You can then hook this up to any backend of your choice, such as EC2, AWS Lambda, or basically any backend service provider. So let's get started and create our first Alexa skill. First thing we need to do is create an AWS account. So basically, creating an AWS account is free for 1 year. You just have to sign in with your credit card or debit card, and then you get free access to their cloud services for 1 year. Since I already have an account, I'm not going to create an account again. I'm going to show you here how you can create an account. Just click create an account and then provide with an email ID, a password, and an account name. The account name can be anything. AWS account will provide you with 12 months of free tier access. This includes EC2, S3, and DynamoDB. For the most part in our application, we'll be using Amazon Lambda, but we can also use DynamoDB and S3 to store our assets. Once you log into your AWS account, it is going to look something like this. You may not have this section which shows you recently visited services, but apart from that, everything should look the same. So now that we are done with our AWS account, let's quickly create an Amazon developer account. So you may want to go to developer.amazon.com/Alexa skills kit, and again all these links will be down in the description below. Now click skills. It will ask you to sign in. If you don't have an account, just create an account. I'll use my credentials, click sign in. Once you're logged in, you'll see something like this. You'll not see this thing because I have a skill which is currently live. All you have to do now is just click create skill. On the next page, give a name to your skill. I'm going to name my skill crypto market skill. Now select a language which you want to target. I'm currently living in India, so I'm going to select English India. Click next. Now you'll be presented with a screen to select a model. So as we are creating a custom model, select the custom model and click create skill. On the next page, you are going to see the build page. This is the page where we are going to spend most of our time. This right section features a skill builder checklist. This is just a list of steps you want to follow when you are developing your skill. We'll come back to this page in some later videos, but for now, let's switch our focus to the serverless framework. Serverless framework is the principal tool which we are going to use to develop our serverless application. So this will be the application which will serve as a backend for our Alexa skill. Now let's install serverless in our local machine. For installing this in our local machine, we are going to need something called npm, which is Node Package Manager. If you haven't already installed Node.js in your machine, I would suggest go ahead and install the long-term support version of Node.js. I already have it installed, so I won't install it again. Now that you have Node.js installed, we'll test it in our command window. Open a command prompt and type node. The cursor will turn into a greater than sign, and then type console.log hello world. Now we know that Node.js is working perfectly on your machine. We will install serverless framework in our local. Just copy this and we'll have to cancel this first. Press Ctrl C 2 times. Now paste it and press enter. It will take some time, but it will be installed. So as you can see, the installation is complete now. Your logs may be different because I already had it installed. It's not an issue. Now that we have serverless set up in our local machine, all we need is an API key for our AWS account where we want to deploy it. For this, go to your AWS Management Console, search for something called IAM, or you may have it here. You should be very careful while using this console, as it may allow any attacker or any other user to have full access to your account. This IAM console allows you to manage programmatic access to your AWS account. This allows you to control your AWS account right from your terminal or by using any kind of programming language such as Python, JavaScript, or anything. If you have never accessed IAM console, you may see 0 users here. So click this users. You may not see this here because I already have a user created. So all you have to do is click add user. Now give a name to your user. I usually stick with the name of the application and then hyphen user. So in my case, crypto market user. This makes it easier for me to remember what kind of application this user is serving to, and if the application is no longer used, I may go to my AWS console and delete it. Now check this checkbox next to programmatic access. This allows an access key ID and secret access key for AWS API, CLI and SDK access. So basically they're saying is you can allow a program to access your whole account. Click next. Now go to the tab saying attach existing policies directly. Search for administrative access. This provides full access to AWS services and resources. Now come down and click next, review. Click next, create user. You should see this screen, and now let's copy this access key ID and secret access key at a safe place. So I'll quickly go ahead and copy this here, an access key ID. Yeah, because this is the only time you'll be able to see. Once you close this, you will never be able to see your access key. Of course, you can also generate a new user, but then you'll have to go through the whole process again. Once you click close, you will come to this page where you can manage your users. You can add a user or delete a user. One more thing, your access keys should be kept very securely because these allow any user, anyone to have full access to your account. So please do not commit these files and keep them very secure in your local machine only. Also do not use the same keys for your production environment because these have access to your whole AWS account and you do not want that. The boring part is over now. In the next video, I'm going to create a serverless application and then deploy it to AWS Lambda using the access keys I just created. So stick around and see you guys in the next video. Thank you for watching and let me know in the comments below what kind of application or skill you are going to build with AWS Lambda and Alexa Skill Kit. Don't forget to like and subscribe so that you don't miss anything from the channel. Stay tuned. Happy coding.
Hello everyone, Anand here, back with another video. In this video, we are going to continue creating our Alexa skill using Serverless framework. If you have not watched part 1 of this video, I would highly recommend that you watch part 1 before continuing. The link to part 1 is in the video description below. So let's get started. In the previous video, I installed Serverless by using this command. Now let's proceed by logging into our account by using Serverless. But before Serverless can access our AWS account, we need to configure Serverless to use those API we had created earlier. Let's open the documentation to see how we can do that. I have already installed Serverless on my local machine, so let's see how we can configure Serverless to use those API keys. Our service provider is AWS, so let's click on this link. Going through the prerequisites, we have completed steps 1 to 3 in the previous video. So I will open this link in a new window. This page should have necessary information to set up Serverless framework with our AWS account. I have already created the API keys, and again, if you have not created your API keys, please watch part 1 of this tutorial. The link is in the description below. Let's use the quick setup method shown here. I will copy this and paste in a command window, and then I will copy AWS API key which I had copied earlier. And since we are on Windows, we need to use set instead of export. If you are on Mac or Linux, you should use export instead of set. That's done, and I will quickly do the same for access keys. I'll just paste this here, copy secret from before and paste in the command prompt. Let's minimize these and get back to the documentation. Now we are ready to create a new service. I will copy this command and paste it in a command prompt to create a new service. But first, let's create a new folder. I will name this folder Crypto Market Skill. I will then move into that directory by using cd. Now paste the command I copied earlier. Let's not use this silly name. I'll name my service Crypto Market Skill, all in camel case. On running this command, Serverless framework will kick in and create a bunch of boilerplate code for us. Let's see what we have got in that folder. By listing all the files, you can see there are only 3 files created, and one of them is a gitignore file. So basically there are only two files. Open this folder in your favorite text editor. Mine is Sublime Text, and let's just skip this gitignore file. If you don't know what a gitignore file is, it contains the list of items which are to be ignored by Git while making any commits. Now let's see what we've got inside the YAML file. Right off the bat, it has a lot of comments. This is the name which I gave to our service. Going further down in the file, I see a section where functions are defined. The function which comes from the boilerplate is hello. Under handler, you mention the file which contains this function. In our case, this is the handler.js file. Coming back to the YAML file, you see there is something called events. Events are the triggers for our serverless function. A serverless function can be called whenever one of the things defined under events is triggered. I will copy HTTP since I'll show you how to run a serverless function from browser. You can also run this on a file change in your S3 bucket or run this after every 5 minutes. I'll fix the indentation since YAML file needs proper indentation to work just like Python files. Later I will set up this function to be triggered by Alexa, so let's copy this as well. Now that is fixed, it's time to deploy our application. Go back to the documentation and we'll copy this command and paste in the command window already open. Make sure you're in the folder crypto market skill or whatever you had named your service. Looks like something went wrong. Oh, I know what that is. This is an error due to indentation I was talking about before. We need to put a tab here and we should be good. Let's try that again. As you can see, it has started bundling the project into a stack, and the cool thing about serverless framework is that you don't have to worry about any dependencies. You may have used several npm modules, but serverless will take care of bundling it and deploying it to AWS S3 bucket. It will do a couple of things during the deployment. It will create an S3 bucket to deploy all your assets, which includes the code itself. It will set up API gateway, which is just another AWS product to access our serverless function from our browser. So it's basically like hitting a URL from your browser and it will trigger this function. And this is not all. It will also set up AWS CloudWatch, where you can monitor your Lambda function. Anything you put in console.log inside your function will be shown in CloudWatch logs. It takes some time during the first deployment since it has to create everything. Once the deployment is complete, it provides us with a URL with which I can run the function using my browser. So let's just copy this and paste it in the browser. I will increase the font size for better visibility. And now let's see the message. Now this message in response is the same we put in handler.hello function. Along with it, you can also see the event object which is passed as a parameter to this function. Now let me show you something really cool. Go to your AWS console and search for Lambda. Click the first result and you'll see a list of your functions. Ours is crypto market skill, so I'll click. Now you can see there are a couple of things. There's this Alexa skill which I configured in our YAML file, but I never mentioned anything about API gateway or CloudWatch. Going down here, you can see there's an editor. You can also edit your function here itself, but it doesn't work if you have too many imported modules in your function. There are some more options available here which are out of the scope of this video, but you can go through them if you want to. Now let's see what CloudWatch is. Open your developer console and search for CloudWatch and click the first result. Go to logs and there should be a log group for your function. And again, you should see only one of these. Every time you deploy, CloudWatch will create a new set of logs. Since we have deployed only once, we see only one group. Start is the time when the request started. You can also see the memory used by your application and the time taken to execute, for which you will be billed for. Thank you all for watching, and in the next video I'm going to use the CoinMarketCap API to get data for a cryptocurrency which will be called from Alexa skill. If you like this video, please smash that like button and don't forget to subscribe. Please leave your questions down in the comment section below and I would be happy to answer them. Thanks for watching and see you guys in the next video. Happy coding. Hello everyone, Anand here, back with another video. In this video we are going to continue creating our Alexa skill using serverless framework. If you have not watched part 1 and part 2 of this video, I would highly recommend that you watch them before continuing. The links are in the video description below. So let's get started. In the previous video, we set up serverless framework in our local and deployed our first serverless function to AWS Lambda. In this video, we are going to build our skill in Alexa skill builder and then create a backend for it in our local using the serverless framework. Let's start by giving our skill an invocation name. An invocation name is something the user will say to begin interacting with a skill. It's like the name of your skill. It has to be simple and catchy. I'll simply use crypto market, and you can choose this to be whatever you want. Next we come to intents. I will quickly add an intent. I'll name it get price intent. So an intent is an action that needs to be performed based on what the user says, and you can create as many intents as you want. Next is sample utterances. An utterance is a sentence which the user will say to trigger this intent. So let's just add a few intents. What's the latest price of? And again, I don't want to hardcode the names of all the 1400 or so cryptocurrencies. That's why I'll use a slot named coin name. It will hold anything the user will speak here. It may be Bitcoin, Ripple, Ethereum, anything. We'll get back to slots, but before, let's add a few more utterances. Now I need to define the slot I have used. It needs a data type just like variables have in programming languages like C++ and Java. There are a lot of them, but in our case, let's just stick to amazon.search query. For now, this is all taken care of. Let's get back to our serverless application. I have created a GitHub repository so that you don't have to copy all the boilerplate code. This will serve as a starting point for all your future Alexa skills. A master branch has all the code in it, but let's go to a different branch, v3 start, and we'll together modify this code to reach to the master version. So let's clone this repository. Copy this from under clone or download. Open a command prompt and write git clone and paste the URL. You can optionally specify a name of a folder in which you want to copy it. And now move into the folder by using cd. By listing all the files, I see that I'm on the master branch. And by the way, I'm using git bash, so that's why it's showing here. But in this video, we are going to use v3 start branch. So let's check out that branch. I can simply say git checkout v3-start. So let's pull this up in our favorite editor. I still use Sublime Text like a caveman. Now open package.json. You will see we have some dependencies. Now open package.json. You will see we have some dependencies listed here. So I would quickly do npm install, and this will install all the packages listed here. Opening the main.js file, you will notice that there are a lot of things here. There's this Alexa library we are including, and then there are a lot of logs. You can set your skill ID here, but it's not required. Here we are registering the handlers for different intents. Finally, we are here executing the skill. Now let's go through the handlers. In default handler.js, we are handling the intents which are required by Amazon. I like to keep them in a separate file because they almost never require any modification. You can see the three intents which have the same name as the ones given on skill builder. Now let's go through the main handler.js. You can pretty much say that this is the brains of the application. Here I have defined the get price intent, which is the same as defined here. Here's how you receive a parameter from user. It is there in the event object which we saw in the previous video. Let's quickly go through the YAML files and see what has changed here. You can see only two things have changed. First is the file name and the other is the name of the function. Previously, if you remember, the file name was handler.js and the function name was hello. Now the function name is handler and the file name is main.js. Now let's quickly deploy this and test from the skill builder. I will type serverless deploy, and there's one more thing to do before we can test our application. So we need to link Lambda and Alexa skill by providing each other's ID. So they basically have to know each other before they can transfer any data between them. So let's open our Lambda console, and now the one already present here is created by serverless and doesn't support authenticated requests. So let's delete this and create a new one. Click Alexa skill in the left here and it says configuration required. Come down and you see there's a place to enter the skill ID. We can get the skill ID from here by clicking endpoint in the left sidebar. So copy the skill ID from here and paste it in the text box here. Also copy the ARN from top right here and paste it in the Alexa skill builder page. Now let's save and build this model. Okay, so now we are ready to test this model. I will enable this toggle and let's try this. Launch crypto market.
You can ask me things like, what is the latest price for Bitcoin or current price of Ethereum? What can I help you with?
So that worked pretty well. You can see the response object. It contains output text and card, which contains the response. And this is coming from here. Also see that we are not ending the session here, so I can simply ask, how is Bitcoin doing without invoking the skill?
You have asked for the prices of Bitcoin.
It's usually a good idea to keep the session open. So since our output is configured this way that we return the parameter passed, so now we know that the inputs are coming through. Now let's quickly use the CoinMarketCap's API to get the price for our favorite coins. First, we are going to need a popular HTTP request library called request promise. This is an extension of the library called request, and it allows us to use promises for our HTTP calls. And you don't have to worry about it, we have already installed it during our npm install. I will pull up the documentation for this. We are going to need this. And let's organize our code a little bit. I will put this URL in a variable and use it everywhere else. Or better, I should move this into a configuration file I already have. Now let's copy some more code as I'm lazy, and let's do some quick formatting. Never be lazy to format your code. Let's name this body and simply log the response in console, and it will be visible in CloudWatch. Let's catch any error that may happen and log that as well. Now prepare the responses for Alexa skill. I will copy this and move it here and reformat everything. So speak is where you want to put everything Alexa says, and some devices have a screen, so everything under card renderer would be displayed on that screen. Now let's deploy this. Launch crypto market, and then how is Bitcoin doing? Let's see.
There was a problem with the requested skills response.
We have an error, intent request, get price intent, coin name. So the intent is fine and the parameter is also fine. It must be our function. Then let's see in the CloudWatch if we have anything. Okay, here's the response from CoinMarketCap API. Cannot read property of card render of undefined. So let's see. Okay, I got the problem here. When you are using promises, you are creating callback functions which have their own version of this variable. To avoid it, you can save the outer this variable into another variable and use that inside the callback function. Or what I like to do in these situations is use arrow function notation, which are the syntax of future, that is ES6 JavaScript, and since we are using Node.js, we can use these. It's much more cleaner and makes your code look more readable. Now let's deploy that again. Let's test this one more time, and let's check out the logs once. So no errors here. Let's continue with the next step. Okay, now we need to get the prices of whatever coin name is passed in the request. So let's get the price from response. I will first pass this as JSON and save it in result variable. Now let's see, we need to compare the name of every coin object to see if it matches with the coin name variable in our code, and then return the price. So let me do something. No, this is not the best approach, but hey, this is not a JavaScript tutorial. There are better ways to do this, and we'll talk about them maybe in a different JavaScript video. There are better ways to do this, and we will talk about them maybe in a different JavaScript video. So I will also add a response in case we are not able to find the coin in API list. Also, response.listen is used to reprompt the user for a response without invoking the skill again. So the session will remain open for around 8 seconds before it closes automatically. I will reuse this piece of code to check if the coin name is actually provided by the user. Amazon has strict norms for publishing apps. They will manually review each app and give you a detailed feedback. I had to put my previous skill 3 times into the review before it was accepted. So make sure you are handling the errors very well. Now finally, if the coin is found, I want to return the price, which is price underscore USD from the API object. Now it's time to test the app again. Let's do it directly this time. Ask crypto market how is Bitcoin doing. So we are getting the same response here. Let's see. This should be a variable and not a constant, because if you are using it as constant, it won't let you modify. So if we check the logs, there must be an error there, and here it is. Now one more deployment. Let's test it one more time.
The current price of Bitcoin is $9,062.81 per Bitcoin.
And there it is. The price of Bitcoin told to you by Alexa. I wish it was over $15,000. Anyways, let's check how Ethereum is doing.
The current price of Ethereum is $633.67 per Ethereum.
Okay, not bad. Let's check one more time for Ripple.
The current price of Ripple is $0.830158 per Ripple.
Cool. Of course, you can make this a full-fledged portfolio app and ask a user about their investments and then track their portfolio and whatnot. I have only used one intent and a small function to show how things work. You can add as many as you want and have a really great application within no time, since you don't really need to code a front end here. Let's see how you can publish this skill to the Alexa skill store. Click launch here and you will see a list of items you need to fill. Make it fancy. Whatever you type in here is directly reviewed by Amazon and seen by the customers. So make a good impression and advertise your skill. Once your app is published, you can also check the number of users, sessions, intents called, utterances, and whatnot. So as you can see, creating a skill is not that difficult. It's just a lot of configuration, and once you get done with the initial configuration, you can really pick up the speed and create a skill in basically no time. I hope this tutorial series was useful. All the code you see in this video is linked in the description below, and feel free to fork and create merge requests if you see any room for improvements. Thank you all for watching, and I hope this was helpful to you. If you like this video, please smash that like button and don't forget to subscribe. What skills are you planning to make after watching this series? Let me know in the comments below. Thanks for watching and see you guys in the next video. Happy coding!